Yeah, hello everyone. My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best, and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into the cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 90th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
Naveen, you can start now.
Okay. Sure. Okay. So yesterday, we have discussed how to install Hadoop and what are the various components available in our Hadoop ecosystem. So, and also I explained how we can install or set up Hadoop in using three ways. So we have um, cloud environment available. We also have on-prem. So on top of Cloudera, on VirtualBox, we can set up a Linux machine like Ubuntu, and we can set up Hadoop. And third option is the Cloudera. So that is a distribution that contains all the Hadoop ecosystem tools. So this bundle you need to configure on VirtualBox, and after executing Cloudera, we have this machine ready. So now today, I will show you how to run MapReduce jobs and what are the various limitations we have with MapReduce. And then we'll switch over to Sqoop and Hive and other ecosystem tools available in big data ecosystem. So this is Hadoop user interface. So here we can see HDFS, so Hadoop distributed file system, where we store the actual data. Can you help us with the installation? Yeah, I can. If somebody want to share the screen, I can. I can help. Geeta, if you want to share your screen. Okay. So, so remove this. Open one more terminal. Okay. Okay, fine. Now, write sudo apt-get install update. Can you provide access to me? I will just provide the screen access to me. Oh, no. Aman, can you provide the screen access? You there, Amar? Change me. Please change me. Uh, you need to provide screen access to me so that I can access your screen and do the execution. Hello. So what I'm saying, just give me the screen access so that I can run the commands. Yeah. Okay, no issues. So write clear. Geeta, write clear. And now write sudo space apt hyphen get. No. Apt hyphen. There is no space after apt. Get space update. And give the password. This user is not the sudo user. Su root. Yeah, enter. Give the password. You're giving wrong password. You're not giving the correct password, I think, believe. Yeah, just check your password, and once you got the password, then let me know. I will explain. Do you guys want me to install this thing again, the Hadoop environment, or I continue with the MapReduce? Okay, let me share my screen. So now this is Cloudera environment. Okay, and here this is the GUI. So we can see HDFS, Hadoop Distributed File System, and here we store our data. Not able to download Cloudera. Can you share the shared drive link? Let me upload. Yesterday there was some drive link. Can you share the drive link? Aman? Aman, you there? Hello, Aman. No issues. I will upload Cloudera on the drive. You can download from there. So see, here this is your HDFS. Here we upload our data. So now practice some HDFS command. So there are some HDFS commands through which we can communicate with our HDFS. So first check the IP of the system. So IP of this is this. So connect Cloudera with Putty. Putty is on Windows only. Okay. Now here Hadoop file system -ls. So this command checks the number of files in the directory. So here we can see all the files. So on GUI also we can see these files. Where is the GUI? Here on the GUI we can see the files, and here using command line we are interacting with the Hadoop environment. Please explain Cloudera installation. Cloudera, this is VirtualBox. This is VirtualBox, and you need to download Cloudera. That software I will share. Let me show you. This is Cloudera. You need to download this. I will share the link. After downloading Cloudera, now go to VirtualBox. This is VirtualBox. Then file, then import, and then give the path where you have downloaded Cloudera. This is our path. Open, and then next. And then it will automatically pick the software, and it will, once it is picked, then after that, click this green button. It will automatically install everything for you. Okay. You need to import this software in VirtualBox. It will be automatically set up. It will take 15-20 minutes based on your machine configuration, and it will come up with this window. Okay, this is Cloudera installation. Now, once this platform is available, now you can explore this interface. So this interface comes with a operating system. So by default in Cloudera, they have given OS as CentOS as the OS, and also it provide Apache Hadoop, wherein you have MapReduce and HDFS both. It provided Apache Spark. It provide Hive, Sqoop, Pig, HBase. So these tools are pre-configured or pre-installed in this, and you can see here, this is Spark, this is Oozie. Oozie is the job scheduler. This is HBase. HBase is NoSQL engine. We also have Hive. So if you want to see Hive, so this is the query editor, and here in the editor we can see Hive, Pig, Spark, MapReduce. So everything is available here. Every server is pre-installed. That's the main benefit. You don't have to install things manually. Okay. Now go to HDFS. This is Hadoop user interface. So here go to HDFS. So in the files, this is HDFS. This is where you dump your big data. Okay, in this directory. This is your file system, Hadoop distributed file system. So here I'm using GUI, means this interface. Right now I'm the admin and I'm controlling this. But when you are working in a real environment, in on the projects, so you access this Cloudera server on your machine. So how you access? Just treat this Cloudera as a server. This is a Hadoop server, and on this server you have everything. You have Pig, Hive, Oozie, Impala, Spark, everything. Now on your, this is a different OS, Windows. Now you install Putty. Putty is here. Now using Putty, connect with that server with Cloudera. That is on CentOS operating system. There we have different operating system CentOS. Okay. Now you are connecting with that server. So you need the server details. So how you get the server details? Go to this terminal. This terminal is kind of CLI, is CentOS CLI. On Windows, we have CMD. On Linux, on Ubuntu also with OpenTerminal. This is another Linux flavor. CentOS is just like Ubuntu. Both are Linux. So it's the terminal. And here we are checking the IP first. IP of this environment. So IP of this OS is this 9260. This is the public IP. So now just put this IP in putty so that putty connect from window. Now the password is Cloudera. Default password is your Cloudera. Now you are connected from Windows to this server, this Hadoop server. Okay. Okay. So now here we can check whether Spark is available. Just verify your environments. So if I write PySpark, it start Spark shell. Okay. You see, Spark is available. We can check Sqoop version. So if I write this command, we can check whether Sqoop is available. Yes, Sqoop is available. We can check whether Hive is available. So Hive is also available. Okay, Hive is available. Now, write some HDFS commands. So HDFS command to interact with HDFS. So I want to see the number of files in HDFS in Hadoop distributed file system. So we write Hadoop file system -ls. So it will give the list of directories. So it give all the directories within HDFS. And this thing you can verify here as well, that it's showing all these files and directories. So using GUI also you can verify that it's showing. So this is the HDFS. This is how we interact with Hadoop file system. Let me execute more commands. Okay, so we can create directory as well in HDFS. So using command, so Hadoop file system. Okay, these are because files HDFS is also a file system similar to Linux. So commands are more or less similar. Make directory, and then this is the existing directory. This is also existing directory, and create a directory here. Let's say test directory. Okay. Now using this command, we create directory inside HDFS. So now directory is created. Verify your directory. Hadoop file system -ls. So if you see test directory, this is the directory. Okay, we can verify this using GUI as well. Go here. This is the directory, and inside that test directory, this one. So this directory is created. We can upload files in this directory. So how we upload a file? So Hadoop file system. So first check whether any file available on your local. So go to desktop here. From desktop, we will upload to HDFS. Okay. So checks any file. So demo file. So check the data. We check the data of any file using cat command. So there is the data inside a file. Now upload this file on the directory that you have created in the previous step. So Hadoop file system -put, and then the path of the local means the file is on local on desktop. So home, Cloudera, desktop, demo file, and now path that give the target path. So target path is this. This path is within HDFS only. So we have created test directory 23. So this is the source path. Source path is the path we are uh, from where we are uploading the files, and this is the target path. So in this directory we are uploading. So if I run it, so it will put. So now file file is there. Now Hadoop file system -ls and check the files within this directory. User Cloudera test directory 2023. Now here it will show what happened. Where we have uploaded the file. We have uploaded the file. But why it's not showing? We can from interface we can upload desktop file. The file is uploaded, but why not using command? Delete the file and check once again. So do file system -put. Put user already exist, but showing the there's something wrong. Test directory 2023 and test directory. Okay. No. Wait. Directory is test dir. But I'm also using the same name, test dir. 2020. Oh, 2023. Oh, okay. So let me upload once again. 2023. Yes, you are correct. So this is the correct folder name. So now we can verify Hadoop file system -ls user Cloudera test dir 2023. Now it's showing the file, the demo file. This one getting called. Okay, so we can see the file, and also we can verify this on the GUI. That file is uploaded, and we can check the data of this file here. And using command, if I want to check, so Hadoop file system -cat command to check the data of a file. So test directory, this and the demo file. So it will show the content of this file. Root file system. Oh, directory is correct. You can use HDFS. Yes, you can use that as well. dir. So you can see the data. Okay. So these commands are the HDFS command. So through which we can interact. Now list of files. We can check the files in a path. Okay. So LSR. So a touch command, it create file in the path. Let's use this. So touch and the file name and the path name. So user Cloudera and 1 minute. I'm telling you, just 1 minute. User Cloudera test. So we create this file. Okay, now verify. So you have a test file.txt. Okay, and LSR. Just path user Cloudera. So it show all the files. You see the read the temp file as well. Yeah, it show all the files, all the hidden files as well. You can see the part files if you go inside this directly. So trash is here, it contains the temp files. If you go inside this, you have these. So it open all the directories. It show all the read files as well. Hello. What I'm saying, it show all the files, all the hidden files as well. Whatever files we have, all the part files, the subdirectories, it show everything. Okay, it show each and every file in the path. Okay, these all are part files. So it is also visible using this LSR command. Okay. So now cat command, I already explained that to see the content of a file, we can use cat command. We can use copy command. Okay. So we can use this copy command. So Hadoop file system hyphen copy, and the copy the user Cloudera test dir 2023 file name is demo, and copy this file is in another directory. So user Cloudera. Okay. So now this file is copied. It's already exists, but you can give any directory path. So this is for the copy. Put command. So I already said from local file system. Local file system means your desktop. You are uploading files into the Hadoop system. Get command. So let's copy files to the local file system. So let's execute this command. Hadoop file system, we can get user Cloudera test dir 2023 file name is demo, and give the local path. So home Cloudera desktop. So it already exists. So first clean the file, delete the file from your local. So just delete it. And now execute the get command. Now it's copied to desktop. So we can verify home Cloudera desktop. On desktop, this file is copied from HDFS. So that is, so put and get. Put is used to upload the files from local to HDFS, and get command is used to copy file from, or you can say it's kind of export, exporting data from HDFS to the local file system. Now here copy from local, it's similar to put command. Okay, so we can write copy from local and the source path and the destination path. Copy to local, so it's kind similar to get command. Okay, move command we can use to move files, remove command to remove. Okay, and if there are multiple files, we can use RMR. So it's for the recursive operation. If you want to clean up all the files in the directory, then we can use RMR. Start just giving the statistics information of a path. Let's execute this. Let's see what kind of start it provides. So Hadoop file system hyphen start user Cloudera test dir 2023. So this folder is created on this date, this time. So this kind of stat information is provided. Tail command. So to check the details of a file, if I execute this, Hadoop file system hyphen tail. Directory name user Cloudera. User Cloudera test directory 2023, and in that we have demo file. So it's showing the content of the file. We also have test directory. So in the test directory, if we use the test command, so there are multiple arguments that we can pass. -e to check if the file exists. Z to see if the file is zero length. If the path is directory else. Okay. Yeah, so it's kind of a test command to check the file size, if file exists or not. Text command, take a source file and output the file in text format. Okay. So let me execute this. With the help of RMR command, can we delete all folders inside particular folder? I think this is for the files only. Let me check. We have this. Let's create one folder. Yeah, Sangeeta. So create one folder here. And dir1. Create. Now create dir2 and dir3. Okay. Now try to run RMR. So user Cloudera purchase related user Cloudera purchase. Now check. So it removes purchase directory completely. Yeah, so it's delete everything. Okay. And in place of RMR, we need to use RM space -R. It's depreciated. It was available in previous version. Now it's a depreciated. So I will share this document. Just go through these commands. So here it display the aggregate length, TU, display the summary. So it's for the permission. So use all these commands. I will share these documents. These are basic HDFS commands. When I am opening Hadoop final in VM, I'm receiving an error. What is Hadoop final? What is Hadoop final? Rakesh, what is Hadoop final? And why you are opening? I said Cloudera, you need to open, but Hadoop, you need to install using commands. If you want to share your screen, I can help. But Cloudera, you need to open directly, and Ubuntu, you need to install. So these are basic HDFS commands. Okay. Now, next is which command mostly used. So HDFS is used for reading and writing the data, bulk read and write. So normally we verify the data in HDFS. We delete the file, we copy file. These files are normally used, these commands. So based on your use case, you can use these commands. And we never got the access of Cloudera in real environment. It's for the admin. We are receiving or we are interacting with Cloudera or HDFS using commands itself, because Cloudera or your Hadoop environment runs on remote systems. Okay, so let me explain the next tool. The first tool, MapReduce. So here, let's consider one scenario. There's a data file. Okay, so let's say we have demo.txt file. This is a text file. And now in this file, we have some data. And now here we have HDFS. And you need to write a MapReduce job. A MapReduce job. And this MapReduce job read the file. And it will count the number of words in this file. Count number of words in the file. This file is placed in HDFS, and after reading the file from HDFS, your MapReduce job produce output in HDFS only. This is MapReduce, and here we have HDFS. So it will produce output in HDFS only. So we are doing a simple analytical operation, the count operation using MapReduce. And MapReduce is a processing tool or an analytical tool on top of HDFS that insert data in HDFS, it do a bulk read, bulk insert. It's a parallel processing tool that is built on Java, and it has all the multi-threaded feature. So let's go there. So it's as I said, your MapReduce is a Java tool. So we need Eclipse to write a MapReduce job. Okay. So you can set up Eclipse on your local as well on Windows. So this Eclipse has come along with the CentOS. So here I'm writing job directly here. Now, uh, create a Java project. Give your project name, word count. And now create one package. This is source code directory. Here, create a package com and create a class. Class name is word count only. Word count. Finish. And here you need to write your code. So MapReduce, mapper and reducer. So let me open the word count program. So official documentation. So they provide, this is mapper class, this is reducer class, and this is our main method. I will explain the concepts first. Just read this code from here. But you see, to count the data in a file, we are writing this Java code. Otherwise, if we have SQL available, we can just do a select count of star. If it dumps this data in a table, then the SQL engine is very easy to when we are doing this aggregate or analytical operation. But that is the first limitation MapReduce. Everyone is not comfortable with Java, and it takes a lot of time to write. Even for a small analysis, we need to write a lot of code. Can we do using Python? Because I don't know Java. I am from non-tech. MapReduce, you just need to see the limitations. I'm not saying you need to learn MapReduce or you need to use MapReduce, but things started from MapReduce only. That's why I'm explaining this. So later on, we will see Spark and how Spark is faster than MapReduce and why we switch from MapReduce to Spark. That's why I'm showing this. So just see one example, then we will switch to Python and other ecosystem tools. But that is the concept that you need to learn. So now here it needs a Hadoop library. So add the libraries. So go to the properties, Java build path, libraries. So these are the libraries, Hadoop libraries or MapReduce libraries that we need to add while we are writing a Java program, MapReduce program. So add external jars, and then here go to file system, and then user lib, and here Hadoop. So go inside Hadoop, and these are the jars that we need to add. So add these jars. These are Hadoop jars. Add more. Go back. Hadoop MapReduce. These are MapReduce related jars. Now click again. Go back. This jars also. Now, okay. And now you can see all the errors are removed. So now those libraries are added in this project. These are Hadoop libraries. Okay. So now this is mapper class. So our class is mapper, tokenized mapper. So when any class extend a mapper class, then it act as a mapper and it override a map function. Here, reducer class, extending a reducer class. When we extend the reducer class, it provides this reduce function. So map is for map is for data read, and reduce is for aggregation. Okay, so let's export this. Export this as a jar file. Browse and export this as word count. Export it on your desktop. We already have 2 files available. Give any other name. Word.jar. Okay. Finish. Okay. And see whether this jar is produced. Yes, word.jar is produced. Okay. Now you need to submit this jar on your HDFS server. So this is a job, MapReduce job. So we have exported a jar file that is a MapReduce job. Okay, MR job. And this job we need to submit on HDFS. So it will start doing the processing. In the processing, it will extract it, it will read data from this file and then do the count of words and write the data into HDFS only. Okay, so let's see how we submit a MapReduce job. So your jar is on desktop. Go to desktop. Desktop. We are already on desktop. So where is the jar? This one, word jar. So now see how we submit a MapReduce job. So Hadoop jar, path of jar file. So our jar is word.jar. Now the package name with the class name. This is my class name. Now the input directory path and output directory part where your data persists. So go to cloud, go to this HDFS directory and see the input file. So my input file is here, demo, and it has 3, you can say rows. Now here it needs to count the number of words. So give the path of this file. This is input directory path, user Cloudera, and the demo, and give the target directory where it produced the output. So user Cloudera, and then you can give test dir 2023. So it will produce the output in this directory. Okay. Now submit it. So now this job is submitted on the Hadoop server. There's something wrong. Already exists. Okay. So it will create one more directory. Let's give 2024. So it will produce a new directory and produce the output. Now job is submitted. You can track this job on this URL. Yesterday when we install Hadoop, so there we modify a mapred site.xml file. So this URL, so this is the tracker. So if I open this, not here, you need to open this here. Go to your Hadoop user interface and jobs. This is job editor. And here job editor. And here you can see that your job is running. Okay, this particular job. So right now it's running. Yeah, this, it's finished its execution. Okay, job is finished. Now check the data, the output that it produced. So user Cloudera, it produced a directory, output directory, test directory 2024, and R is for reducer, because reducer is writing the data. Mapper is your read and reducer is for write. And here we can see it produced a count. So if this data is huge, in billions or trillions, then also it works well, because it do a parallel processing. So let me draw architecture how a MapReduce job works internally. So when we submit a MapReduce job, so it has, this is the first layer. This is the input format class. Input format. The next layer is your input split. Input split. Then the next class is your record reader. Record reader. Then next is your mapper. Mapper. Then next class is your shuffle. Next is your sort. Next is partitioner. Then combiner. Then reducer. So partitioner. Then reducer. And then no partitioner, combiner. And then reducer. Reducer. So this is the complete flow of a MapReduce job. So from here, we provide the input. And here it produces the output. Now, this activity happens on this one, on name node only, master node. On master node. And the rest is happens on non-data nodes, the slave node. Now, in our program, when we write a MapReduce job, we have written a MapReduce job here, this one, this. So we have written mapper and reducer only. We have written mapper and reducer, but these classes are provided by MapReduce, and every class is doing its own function. So input format class is used to detect the file format. So right now our data is a text file format. So by default, text input format class is available. That is the child class of input format, and it will detect the data and start reading the file. But if you have other formats available, let's say we have an Excel file, or we have a PDF file, or we have database, okay, or any other format like JSON, XML. So MapReduce doesn't support those formats. So we need to customize. So in that case, we need to write this class as well, Excel input format. Let's say if we are reading Excel data, there's no pre-built support available. You need to customize. So that is a problem. That is one limitation. It's not supported all file formats. It supported text file only. Now the next class, input split class. So let's say my data file is 1 GB. So this input split class, it do a partition of our data, and partition size is 128 MB. So this is the job of this class to do partitions of the data. Okay. Now after creating partitions, it give those partitions to this class record reader. Now record reader class generates key value pair. So it generates key value pair in every partition. So partition, let's say 10 partitions are created based on this data. So it creates key value pairs in every partition. Now, those partitions are handed over to mapper. Now mapper is launched. There's a formula, number of mapper equals to number of mapper equals to uh, uh, number of splits. Okay. And here we can see number of splits is 10 based on the partitions. So your 10 mappers will be launched. And where these mappers will be launched? These mappers will be launched on the data node, on the data nodes. And who will launch? Master will launch. So let's say we have this master and slave. We have these master and slaves. And here you're in master, this activity is going on that it detects the format, then it do a splits, then recorded it generates key value pair, then mappers. How it decide the mapper? It decide because based on the splits. Now it what will happen? So it launch those mapper equally on all the data nodes. So 3 mapper launch here and 3 mapper launch on the another node. 3 mapper launch on this node and 4 mapper launch on this node. And each mapper is processing 128 MB data. And mapper is nothing, mapper is a thread. Mapper is a thread. Now these mappers are, here we can see it's a parallel processing of our data. Every thread is processing 128 MB data, or we can say every mapper is processing 128 MB data. M8, M9, and M10. And every mapper provide this data to the reducer. It provide data to the reducer. So there's a reducer thread, and this reducer thread is writing this data back to HDFS only, or if we want to write the data in some other place, let's say we are writing in a NoSQL engine or somewhere else, so reducer can write the data in that location. Okay, so that is the complete flow, how a MapReduce job works internally. So but again, writing this Java code is not feasible. So limitation wise, first limitation, as I see, first is this, the file format is not supported. Not all file formats are supported. Another is the language issue. Okay. And the third issue is one is the language, Java issue. We are writing a lot of code even for small operations. counting, grouping, joining, aggregation. Another issue is that it doesn't support file formats, not all file formats. So we need to customize a lot. Okay. Third is batch processing is not available. So batch processing means, so let's say right now I'm processing 1 GB data. Okay. And let's say my data grows and I want to process 100 terabyte data. Okay. So in case of 100 terabyte, what will happen? Now see, in 1 GB data, it create 10 partition based on 128 MB. Now in 100 terabyte, how many? In 1 terabyte, approx, there's 100 GB. You will have 10,000 partitions. And then in 100 terabyte, you will have 10,000 or 10 lakh. It will auto create those partitions. Now it will try to equally distribute those partitions. So if let's say 10,000 partition, so 10,000 partition means 3,000 partition here, 3,000 here, 4,000 here. So how many partition a particular machine can handle? How we will check that? So there's a formula to check how many machine a particular node can take the partition. So for that, we need to calculate the resource. So data node 1 hard disk is 2 terabyte. Let's say RAM is 16 GB and its CPU is 4 core. This is the configuration of data node 1. Now data node 2 and data node 3. Data node 2, same configuration. Data node 3, same configuration. Now in total, how many, the total resource, or you can say total configuration of HDFS is how much? In total, it's hard disk is 6 terabyte and your RAM is 48 GB. RAM is 48 GB and your CPU is how much? Your CPU is 12 core CPU. 12 core CPU. Now, how we can check a particular, how many mappers we can launch on a particular data node. So there's a formula, number of mappers that we can launch on a particular data node is equals to 4 into CPU core. Now here for data node 1 CPU core is 4. So 4 means 4 into 4 16. So 16 means 16 threads we can run at one time. And there are some background threads as well. So let's say there are some background operations. So for background threads, let's say 4 or 6 thread, approx 6, 4 to 6 thread is provided for background operations. So 10 threads are left. So now we can launch a maximum of 10 on this data node. If we want to launch more threads, then we need to increase this configuration. And there is a limit to vertically scale this. There's a limit. So if there's 1 terabyte data, then how we can process this much data? So in that case, we need to enhance the node. We can add more nodes, but it's not feasible to add the nodes every time we are processing our data. We need batch processing so that it processes data in chunks. Thread is again a program that runs continuously. It never died. So thread is used for multi-processing. So here with multi-processing, we able to handle or we can process big data. Otherwise, even a small Python program, Java program, everything is thread. Thread is a program that executes in the memory. Okay. Now this is the whole story around MapReduce. So if we go to the MapReduce, um, so see this MapReduce, as I said, it's a framework or a tool that process large amount of data into Hadoop. Okay, and it runs on the HDFS node. So on HDFS node, as we see here, MapReduce processes data through the data nodes, the HDFS nodes. Okay, so here, if we see this diagram, so this flow I already explained using this. So we have, this is the text file, then the input split class do the splitting, and then after splitting, and it based on the size, chunk size. So 128 MB is the default size. And then the mapper class generates key value pair. And then it goes to the shuffle class. So it do the shuffling in every partition. You see this, uh, this is complete shuffling. And then it gives to the reducer. Now reducer club the final result in this writing data. So this is the process, overall process of MapReduce. And we already discussed this, that how it process through the data nodes. And these are the classes, text input format. These format classes are available. Data input, database input format, Excel input format, those are not available. We need to customize these classes. And if we are writing a MapReduce job, so here, if we see a MapReduce job, so here we use the data types. So for string, we use text. For integer, we use iterable. So these are the data types that MapReduce provide. But the thing is, we are not writing, again, MapReduce is not that feasible. We need hardcore Java programming, and it takes a lot of time to write all these lot of codes. So that's why Hadoop ecosystem tools are available. So let me introduce first tool, that is Sqoop. So at the center we have MapReduce only, MapReduce and HDFS. You have MapReduce plus HDFS, and HDFS we knew it distributed, so it has master and slave. Master is your name node. This is your data node. And now MapReduce is not feasible. So what we can do, so let's say we have a database, Oracle or MySQL, any RDBMS database, Oracle, MySQL, Postgre, DB2, any database is available. And now fetch the data or read the data from RDBMS source and write that data in HDFS. So first option is we can use MapReduce, but MapReduce is again, we already discussed the limitations. So we have Sqoop available. So first we need to install Sqoop server. Okay. So Sqoop server is already available in Cloudera. So Sqoop server. And now we need to write a Sqoop job that we submit on Sqoop server. And we that job, we can say we are a client, or we are, because we are writing the job, and that job will be submitted to the Sqoop server. And Sqoop server automatically converts that job into a MapReduce job, and then it start processing through the HDFS cluster. So that's how the process is. So let me execute this, then you guys understand. So let's check whether Sqoop is available. So Sqoop version. So Sqoop is here. So as I said, we need a source. So this is this is our source system. Source system is your database. And what is your target? Target is SDFS. Target system where we dump the data. Target system is HDFS, or we can say data lake. We call Hadoop as data lake as well. And who is doing the ingestion? Sqoop is doing the ingestion. So we can say Sqoop is a data ingestion tool that ingests data from structured sources, and in structured sources, databases. So it's a data ingestion tool. So data ingestion tool, or we can say EL tool, extract and load. So first check whether source is available. So create one more session. Login as Cloudera. And here check your database source. So MySQL. Is there any difference between data warehouse and data lake? Yes, there's a big difference between data warehouse and data lake. I will explain data lake, data warehouse later on. But data lake, Hadoop is your data lake. And data lake is distributed. We have master slave. In a similar manner, we have data warehouse. Data warehouse is also have master slave. But data warehouse is used to store structured data only. And data lake is used to store structured and unstructured, both kind of data. That's the difference. Data, this is data warehouse. So if you combine multiple databases, let's say if you have Oracle here, and then this is another Oracle node. This is another Oracle node. This is another Oracle node. And let's connect these together. And why we are connecting these systems together? So that we can store huge data, huge structured data only in case of data warehouse. So here you store historical data. Historical data is a huge data, and it's the structured data only. Structured. And we store this data in form of tables. First, we need to create schema, and the kind of tables that we create within data warehouse is using dimension modeling. So you guys are not aware of dimension modeling, but here we design our tables using star schema and snowflake schema. But again, structured data only. And in our data lake, we store structured, unstructured, semi-structured, any variety of data. And there is no schema. It's just a file system. You can dump your data, whatever format you are receiving, just dump the data in a data lake. That's the difference. So now our source is database. So your database is here. So MySQL. Okay. MySQL -u, username root -p, the password is Cloudera. So this is your database. Now prepare some data set here that we need to dump into data lake or Hadoop. So use MySQL database, show tables. And these all are the tables available. So let's drop employee table and recreate this table. So create table employee ID is the primary key. Email. Okay, now insert one row, hundred Tom, and the email ID of Tom. Now insert another row, and now verify the data. So now this data is prepared, and now check whether Sqoop server is available. Sqoop server is here. Now start writing Sqoop job. So instead of writing MapReduce job that is in Java, we are writing Sqoop job that is a command line tool. Here, very easy commands we need to write. So Sqoop import. We are doing the import from HDFS, import from MySQL or database to HDFS. So Sqoop import provide the connectivity details so that Sqoop server connects to the source system. So using JDBC, MySQL, your database is running on local. So that's why I'm giving localhost. This is the database name. Then the username of your database. Username is root. Then the password of your database. Password is Cloudera. And the table that we need to ingest or import. So it's the table name. Table name is employee. And that's it. The target, by default, target for Sqoop is data lake only. So there is no need to define any target location. Okay. So this is the command. Now, first check whether data is already there or not, because it's a full import. So employee data, just clean this directory, otherwise it will throw exception. So now submit this is this command. So when we submit this command on the Sqoop server, you see this diagram. So we create the job. So when we submit the job on the server will convert that job into MapReduce automatically. And then once it converted into MapReduce, then it follow the same process. So which process? This process. So it will detect the format, then it will create the splits. And then after creating splits, it pass those to the record reader. The number of mapper will be launched on the data node and then start processing. So let me submit the job. So now job is submitted on the Sqoop server. There's something wrong. Password, 1 minute. Hyphen capital B. Now it's asking password at runtime. Password is Cloudera. Again, something wrong. JDBC column MySQL. Password is Cloudera. Now it's start processing. So here we can check the logs. So first is it's doing the code generation. So it's generating the code after, and it's generating code onto this location, that MapReduce code. And now here in the logs, you will see it's submitting a MapReduce job on the server. So here, see, MapReduce job is running. This is a MapReduce job. Okay. So Your job is running. It's still running. So it's let me check. Yeah, so job is finished. So here we can see the data is transferred to HDFS. Go and check the data. So here in HDFS, it created directory based on the table name. So it create employee directory. And if we check the directory, mapper is for read. So here we are not doing any transformation. That's why there is no reducer. So this is first row. This is row number 2. So data is successfully inserted. Now verify what kind of code it generates. So if we see it produced the code in this directory. Okay. So go and check what kind of code it generates. So it produces a Java code for us, a MapReduce job. So here, go to this directory, file system, temp, Sqoop Cloudera, compile, and here we can check uh, this one. And inside this, 1 minute. So this kind of code is produced. This. So this Java code is produced by Sqoop server. That is a MapReduce code. So instead of writing this whole code, Sqoop is helping us to do an ingestion without writing the MapReduce job. We can use Sqoop commands that will be auto converted into MapReduce and do the ingestion process for us. So that is the benefit of using that. That's why Hadoop provides these ecosystem tools like Pig, Hive, Sqoop, so that we don't need to write this MapReduce job. We can easily perform our ingestion or analytical activity on top of HDFS. Any question? Any question so far? Hello. Sangeeta, you were saying something? Okay. So now there are various, you can say, commands available or tools available within Sqoop. So as we can see here, we write here when we ingest the data. So it launched two mappers. When we see the output, there are two mappers. So, but I don't think two mappers are required because our data is very small. It's hardly in KBs only. There are two rows only. No question. Okay, thanks. So there are two rows. So it's hardly in KBs. So why two mappers are launched? It unnecessary impacting the job performance because two threads are launched. So in order to we can optimize this. So based on the data size, we can optimize our job. So what we can do, we can rerun this job again with one mapper only. So hyphen mapper one. So now this job will be launched by one mapper only, and your job execution will be fast. So a previous job is finished in how much second? 142.500 seconds. And now let me submit this job again. And this is a full import. So you need to clean up. You need to clean up your directory, otherwise it will throw exception. So all we can do, we can add a target directory. If we don't want to write the data on the similar directory, so we at the end, we can define target directory in HDFS. Target hyphen dir, and target directory is user Cloudera and give employee dir. And this time we need one mapper only because my data is small. It's in KBs, and we knew that one mapper process 128 MB data. That is the optimal number we have. So submit this job, and you will see this time your job execution will be fast. Yeah, so missing argument for table. Okay, yeah, table employee. Password. So again, it's producing a MapReduce job. I'm producing that code in this directory. This time it so we can see in the logs number of splits. The number of split is 1 because our data is below 128 MB. In the previous job, and based on the splits, it create mappers. I explained this formula earlier, that number of input splits equals to number of mappers. Okay, and this time your job finished in 46 seconds, so it's faster comparison to the earlier one. And see whether data is successfully ingested or not. So user Cloudera, and here we can see it create a target directory, and there is a single mapper. This single mapper, not this one. Single mapper ingest all of the data from my table. Any question on Sqoop, on MapReduce, how we configure all this? how to submit Sqoop jobs, why is Hadoop introduced Sqoop if we already have MapReduce. Cleared or any issue? Until we execute, no doubts. Okay, so you can um, okay, let's set up the environment. So I'm giving 10-15 minutes so that whatever I have covered, you guys can install and do practice. Okay. So I'm stop sharing my screen. Anyone can share the screen so that I can help with the installation part. And also, Aman, can you share me the drive link so that I can upload the software? Am, are you there? Amar, you are on mute. Anyone is sharing your screen? Hello. If anyone is, Sangeeta, you are sharing? Or Shranayak, Sharanya? How how I help with the installation if no one is sharing? Are you guys listening? Am I audible? Provide a little bit about Sqoop even if we have MapReduce yarn. Provide a little bit about Sqoop if we have MapReduce yarn. Yeah, so I already explained that Sqoop is a wrapper tool on top of HDFS that is used for, you see this diagram, the architecture. So here what I have shown. So there's a database and I want to ingest the data from the source system. Yesterday I tried to download VirtualBox, but I'm getting some error. It is possible to download Cloudera software directly in the Windows. No, it will not work for Windows. First, uh, you need a VirtualBox, or another option is install. Um, First, download VMware, VM Workstation. That is also option if uh, you guys are not able to install VirtualBox. Okay, so download this uh, VM Workstation, and then for VM Workstation, software is different. This is for the VirtualBox. For VM Workstation, let me could not unmute this allowed by host. Okay, yeah, no issues. I thought it no worries, it's fine. So this VirtualBox is for Oracle VirtualBox. I will share VM Workstation. Okay, uh, share the link to download. Yeah, let me just 1 minute. This is for VMware. Okay, let me. This is if Oracle VirtualBox is not working, use this link. Download VM Workstation, and now download your Cloudera. So download Cloudera Quick Start VM. they have changed the link. Let me check. And where is quick start? You need this page. So Cloudera will tell me the application of this software. No, this is not application. This is a tool. Um, so I have this tool handy on my local. I will upload on Drive, but let me check if I able to find the link from somewhere. So just 1 minute. Then find it. So first create account here and then CDH5. CDH5. You need this page. Quick start for CDH5. Cloudera start for CDH5. They have changed this recently, so that's why direct link is not visible. So we can go here. Virtual box we need to set up. Then the downloading of this, but again, direct link. Okay, let me find the direct link. Otherwise, I will share the drive link. I have this software. I will upload on the drive and share. So you just need to unzip this and then on the Oracle VirtualBox, just import this from here. Okay. So we have covered Sqoop so far. So in Sqoop, there are other tools available. I will go in detail from tomorrow session. But just to give you a brief, what we will be covering from tomorrow onwards in Sqoop. So we have studied Sqoop import. We will see Sqoop import all tables. So it will import all the tables from our database into HDFS. Then we have export available. Export is exporting data back to RDBMS, or we can export data from HDFS to some NoSQL engine or some other systems. Then CodeGen. CodeGen is used to generate a MapReduce code. Using Sqoop, we can create Sqoop job. We also have validate. So validate is when we are doing an ingestion process. So and data is ingested from source to target. So whether data is successfully transferred. So if I have 100 rows in my source system, so all the 100 rows are successfully transferred, or some rows missing. Sometimes it happened due to network issues or some exception. Some rows are skipped. So that is the validation thing. So we'll see validation also. Then we'll see Sqoop meta store. Okay. And then after covering all this, we will see list databases. There's a command available. Okay. Just one second. Okay. So uh, we have list databases. Okay. And there are certain concepts that we will cover. So in the concepts we have any content. Yes. So content is here. So today I will share the content, the MapReduce one. And for Sqoop, you can study this. I will share this at the end of the session. So as we can see, Sqoop is SQL plus Hadoop, but it's not SQL. These are just the commands that we are submitting on the cluster. So these sort of commands we are submitting. So uh, where is that? Yeah. So it's again it's a Apache tool. It's an open source tool, and that extract data from structured sources into Hadoop. Okay. And Sqoop uses MapReduce. So as we see, our Sqoop job is auto converted into MapReduce. If we see the logs, it's converted into MapReduce. Okay. Then by default in Sqoop, there are 4 mappers. That thing we'll study tomorrow. This is more detail. So let me write the default mappers in Sqoop. Okay. So default mappers. Then next second concept is controlling parallelism. Controlling parallelism. Then third is boundary query concepts. Boundary queries. Then next is your incremental import. Incremental import. So currently the scenario that we have covered today. So here this is full import. This is not an incremental import. So that's why I'm deleting the tables. I'm deleting the directory in HDFS every time I'm running the import job. So in case of incremental import, it just import the newly added records. Okay, it will not do a full import. Then we will see a join table import. Join table import. Yeah, so that's it for the Sqoop. So all these concepts we'll cover in the upcoming sessions. So again, I said it's a ingestion tool. So it by default it uses 4 mappers. Okay, and we can import data from any RDBMS source. Now in RDBMS we can have Teradata, Netezza, Oracle, MySQL. So it uses JDBC connection. So that JDBC connection we already seen that when we are writing the Sqoop import, so it's doing a JDBC connectivity with the source. Okay. And Sqoop is also written in Java internally. As I said, it's converted into MapReduce. So it's internally it's Java only. Okay. So we can import one table. We can import, if we want to import one table, we use Sqoop import. If we want to import complete database, then we use import all tables command. We can import selected tables. We can import selected columns and selected rows. That I will show tomorrow. The selected rows and selected columns. And then feature wise, uh, Sqoop generates the MapReduce code into a processing with the help of MapReduce internally. Okay. As I said, it uses MapReduce to read tables from database. We are not writing the code. Sqoop is writing the code automatically for us. Okay. It supports JDBC connection and it support text file, Avro file. Now this is the Sqoop architecture. So here we can see we are the user. We are submitting the command on the Sqoop server. Now Sqoop server is fetching data from these possible sources. So it can fetch data from a database. It can fetch from a data warehouse. Data warehouse is structured only, or it can fetch data from document-based system. These are also structured only, but mainly we use database only. Okay, so these are the source and the target using map task. So when we see, whenever you see the Sqoop output, so it's producing result using mapper only. M is mapper. So there is no need for reducer because it's an ingestion tool. And using mapper task, it fetches the data and then it writes the data into HDFS, or we can write in HBase or Hive. So that I will cover in this part, Hive integration. In Hive integration, we can integrate HBase, we can integrate MongoDB, we can integrate Cassandra, any NoSQL engine we can integrate with Sqoop along with Hive. Okay. So that will cover during the integration. Okay. So now in Sqoop 2, they provided web interface. So if we see here in the UI, we have a Sqoop editor, this one. So here we can write our Sqoop commands. Okay. Here we can write Sqoop import. This editor is provided, and now if we see that connector, so MySQL connector is available, but if we want to import data from Oracle SQL Server or any other database, what we need to do, we just need to go into the location where Sqoop is installed. So Sqoop is installed in user lib Sqoop. Sqoop, where is Sqoop? This one. And here in the lib directory, here we can place the database jar. So whether it's MySQL or DB2 or Postgre, we can dump the jar here. So Sqoop will auto connect with the source system. Okay. So that's the connector part. And we already written these commands. Okay. Sqoop import command, you already seen that Sqoop import is for the import purpose from RDBMS to HDFS, RDBMS to HDFS, and it will run a MapReduce job internally. And by default, Sqoop uses 4 mappers. Okay. We can change the mapper limits based on our data volume. Okay. And also we can do an incremental import, but today I cover full import. Tomorrow I will cover incremental import. Now incremental import means, as I said, the newly added data, the incremental data on daily basis. Export is a reverse. Export also I will cover tomorrow, the export process. It's a reverse of import. So that's it for the Sqoop. So I will share this this document and also the commands. So these commands are written here. So you guys can use um, these commands. Okay. So here these templates I will share and use these templates to understand these commands and execute these commands one by one. Okay. Now, any question? That's it for today. So today we covered MapReduce. We have covered MapReduce limitations. We have seen one tool, ecosystem tool, Sqoop, that is used for the data ingestion purpose. So instead of writing a MapReduce, you can use Sqoop to ingest data from RDBMS sources into HDFS. Now, tomorrow, once we covered Sqoop, I will cover Hive, and we will see how we perform analytical operation using Hive. Okay. I will share Cloudera link as well for the installation and this the study material. No, Cloudera is MySQL is pre-built, pre-installed in Cloudera. There is no need to install. Yeah, so yeah, facility should be given, but XLR management, they will take care. I will let them know.
What is the question, Naveen?
Actually, a participant is not able to unmute. If they want to ask any question.
Yeah, I given the access to them. So going forward, in the last 5 minutes, you will get the access to unmute yourself for your query and question. If anybody wants to talk, you can unmute yourself.
So, anybody is having any question before wrapping up the today's session?
So dear participant, I already shared the attendance link on Zoom and YouTube as well. So don't forget to mark your attendance and share your feedback as well. And if you have any query or question regarding to the LMS, anything else to the LMS or EDL team, let me know. I will help you on the same. We'll upload all the material over the LMS. Oh yeah, if anybody wants to talk, please unmute yourself. I hope all of you are able to unmute yourself. I just given you the access.
Okay, I think there's no question, so we can wrap up, Amar.
Yeah, sure. Thank you so much, all of you. Have a nice day, and we'll meet you on tomorrow.